Hello everyone, my name is Manuel and I'd like to show you how virtual machine works. So imagine that you are trying to emulate a computer that has only 3 instructions, let's say 4. So what we're gonna do is have a enum. This is just for simplification. And then this call this bytecodes. So let's say that the instruction that this CPU that you're trying to emulate has the instruction move, which will be for in the case of assembly. I don't know what the real number is, but let's imagine it's 0, and then has another instruction add. Let's imagine it's the in machine language is really 1, and then has another one called print, and another one called halt, and that will be number 3. Okay, so we're supposed to have the code stored somewhere, the code that this virtual machine is going to be executing. So let's say you have an array of shards, like call it code, where we're going to store all the codes. And then imagine that has the following code stored. Supposed to read it from memory or I don't know, whatever. But imagine that the instructions are as following. I mean that it has the following program that you want to execute in the from this machine. Let's say it's a Nintendo or Sega Genesis or one of those old computers, and you're reading that program and you want to execute it in this one, in this computer that I have. So let's say that the program has the following instruction: one called move, and let's assume the move instruction, because probably gonna need something to move into a destination. Let's say the destination is the first value after the move. So let's say 0, just an arbitrary number. I mean index, and then the number that is supposed to be moving to the memory location. In this case, 0. It will be the number will be 5. So what this is saying, that you need to move the number 5 to the memory location 0, and the memory that we are going to have will be another array of, I don't know, 10 variables, I suppose. I mean, it can handle 10 variables. And then you want to execute this program. So to make this a little easier, I'm going to have instead of a do, let's have a do while. So what I'm going to do is this: have a variable of I of type bytecodes. That's this, just to make it a little easier to see when it's executing. So I will be, and also let me have another variable IP, which will be the instruction that we are executing. So we set this to 0, so you start reading from this first instruction move, and the instructions are stored in this array of code. So IP 0, and then we increase IP to 1 at the beginning. So since this is a different type, we need to typecast it. Okay, so now have a switch statement. so we can tell which instruction we're executing. The instruction is I, and well, this is convenient. You just write all the instruction that I just created for this enum. So I had them moving all of that. So now let me write how this instruction will be executed. Right now I only have the move statement. What are we going to do is remember the first parameter is the index in memory, so we have to use mem and then read the code and see where is the index. So index IP, since we already assuming that we starting from here in 0, so IP 0 is assigned to I, so I has the move instruction, IP is increased, now IP is in 0, I'm sorry, 1, so it's pretty much saying like give me whatever instruction is in position 1 of code, which is this, the number 0. As I mentioned before, move need the location. So the first thing is the index where we're going to move, and then the value that we're going to move to that location. And then obviously the number 5 is storing code, so we get code. But I can use IP. IP is already pointing at position 0, so it had to be IP plus 1. And after I do that, what I'm doing is right here is putting 5 in position 0, so you notice, but I need to increase now the IP pointer to 2 elements. You may be wondering why 2, because right now right here I'm pointing to 0. If I leave it like that, if I try to execute the next instruction, it will be executing 0 again, and that's really not the right way. So if I increase it to 1, it will be pointed to this one, and I don't want it to point to that one because the end of the instruction will be after that, so I had to increase it plus 2, and then I call break. After that, I'm going to put a halt to stop the program so it doesn't execute indefinitely. And let's imagine that this is set for now, and this do will execute until or while I will be different than halt, so it doesn't crash or go beyond the array of code. And then let me just execute this, run the program and see how everything is, if it is doing what is intended. What I'm getting, it's I at IP 0, then it was increased. So right here, the instruction move, and then since IP is 1, so it's pointing to this location. So I use code to get the number in code at position 1. So that will be 0. I use that as an index in mem. So if I select it, you can see what's in code at position 1, which is 0 right here, that. And then what this is doing is using that index and moving what's in code. Not right now, I'm not using memory, just what's in code. Position IP plus 1. So IP plus 1 will be, since it's right here, plus 1 will be 5. So this is, if I select it, you can see the result. It will be the number 5 that is stored here will be stored at position 0 of memory. And then I increase IP to 2. Why to 2? Because you got 2 parameters. If I don't increase it, will be still pointed to this one, and it will try to execute from here. And I don't want I don't want that to happen, so I jump to the two parameters. So IP now, after that instruction, will be pointed to position 3, which, if you notice, 0, 1, 2, and 3. So that'll be the next instruction to execute. And after I did that, you can see that the number 5 was placed in index 0, as it says right here. Then if we read the next instruction, will be the halt, which is saying right here, if it's different than halt, but right now it is, it will break. So the program end. Let's assume that we're going to have a program that has something more useful, something like let's implement the add operator, and then use for this add operator two parameters. One, the index that we're going to be adding. So let's say what's in memory, index 0 will be add to whatever it is in index 1. I don't really have to put the result in another index, so let me just have it like that. So what it's going to do is having what it's in index 0 plus index 1, and then put the result back here at index 0. So that makes it easier, so I don't have to have more extra code, make it a little bit more efficient. So I use what's in index after the instruction. The first index or parameter after the instruction will be add to mem, since they are indexes, or supposed to be indexes, plus 1. So what's in here will be add to what it's in here plus 1, and use that as an index in memory 2. So IP, we increase it to 2 because this instruction has 2 parameters, or you need to have to bypass the instruction. And then let's say we have already have a break. So let's say that we want to define the print also, so we can see the result in the screen. Print, and then print is gonna be the index of the memory that we wanted to be printing. So print f, they are numbers always, so printf what's in memory, add code IP, so what's in this location of memory, and then we increase IP not to 2 as we did before, because it only had to go just after the first parameter. I always forget that the break is right there. Am I missing something here? Yep, another bracket. So if we execute this program, let's debug it so we can go line by line. So the first instruction is move. IP right now is pointed, it's 1. So since it's 1, what's in co position 1, it's this 0, will be used as an index in memory. So it's like saying mem at index 0 will be what's in co at IP plus 1. So number 5 will be stored at this location. Increase the thing, and now I had the number 5 stored in index 0 on memory. Next instruction, it's another move. Let me just jump it because we know the result. So what happened? There's an error here. Okay, so I was getting the wrong number because it's adding what's in memory address 1, but at the beginning there's just garbage. So I needed to have another move before that. Let's say I wanted to add 3 to 5. Okay, so now if I execute it first time, got the move. So I got the number 5 at position 0, like I says here, position 0, number 5. Next one, another move. And I got the number 3 at position 0 again. There's an error here. Index 1, that's what I meant. Index 0 should have 5. Index 3 should have 3. So let's do this again. First time, second time, I just press continue. So first I had number 5. Second time should have number 3 at position or index 1. Next instruction add will add index 0 plus 1, and the result will be storing index 0. So 5 plus 3 equals A. A should be at index 0, and it is right here. The number 3 is still there because I haven't done anything with it. Now the next instruction will be the print, and it's going to print index 0 of memory. So if I see the output, see the number 8, and the next instruction should be the halt, so the program end, and it did. And this is pretty much how virtual machine of languages like Java and others, like I think Python does that, works that way, Lua and some others. Thank you, and have a good day.